All right, so on Thursday, oh no, not on Thursday, on Wednesday of last week, we took a look at 3.3, which is corresponds to section 3.3 in your textbook. And this is some differentiation rules. And so we talked a little bit about the concept of what was happening here, noting that we're looking not for a slope between 2 points now, but rather we are finding a slope at a very specific point, okay? And so doing that, finding that slope at an instant in time is really equivalent to finding the derivative. We talked about some notation, so lots of different notation, and I'm going to try and be really thoughtful about using all of those different notations, just so we really get a feeling for what each one means. And then we went into some rules. So we went into the power rule, and we spent quite a bit of time on that. But specifically, we looked at some cases where it's going to be maybe a little bit less straightforward just because the powers are not just whole numbers. And so in particular, I really want to make sure that when looking at these 5 practice problems here, that we feel very good about these kinds of problems. Okay. Example number 2 should be one that we can all do and feel very, very confident on. But I want to make it very explicit that examples 3, 4, 5, and 6 are also where I want us to be, okay? We did talk about some special cases of rules, and so we sort of embedded a lot of the language within there. That was one of the questions I noticed that folks had, was not knowing quite some of that vocabulary. I would encourage you to look back over those notes before sort of panicking that you don't know what that means, okay? I may also direct you back to those notes if you ask, like, what is this rule? What is this rule? But make sure you go over those. We do incorporate a lot of that vocabulary in there, okay? We talked about that sum and difference rule, where basically we had to string together a lot of those. We can only do this when we are adding or subtracting. And we said we're not going to be doing this for multiplying or dividing because those rules have special names. Okay. And so we finished on Wednesday of last week with the product rule, okay, finding things with 2 different methods and simplifying. But in particular, we said sometimes one method will be more straightforward, more efficient, whereas other times we'll be using a different method, even for the same problem. And so it's really important that we learn about that decision making. When can we use what as we kind of go along? Okay. We clarified the product rule. Again, this proof piece was a bonus level. All right. So more for that idea of like, how do we know where things come from? Why is this formula the way it is? We've got our proof right here. But I will not test you on the proof. However, I will ask you about any of the other things we cover in this section. Okay. We did a couple more examples. Again, here's that constant multiple rule, okay? So if you go back into every section, I've uploaded those, the filled out notes or the complete notes for that day. You can always go back there in case there's stuff that you forgot to write down. It should all be documented in this page, okay? All right, so where we're going to begin today, we are going to talk about quotient rule, okay? So we're going to take a look at quotient rule today and kind of see where that takes us. It was not an expectation that you used quotient rule on the quiz from last week because we hadn't covered that yet. Okay, so keep in mind as you're going through things, websites may tell you to solve a question a certain way, but I do expect us to be using the methods that we learn in class. All right. So with that being said, with all of the time that we spent on multiplying things, now we're going to be taking a look at what it means to divide things. And let's start off with this particular example where, just like with the product rule, we're going to be able to use two different methods, okay? Two different methods. So what are our thoughts for one way that we could maybe simplify what we have here in this question so that we don't need any special rules? Any ideas on how we could simplify this example 13 right here?
Factor out x.
All right, so if we factor out an x, can we be a little bit more specific about what that means? Like, what are we going to do after we factor that out?
Then you should, yeah, then it's, I mean, it's just straightforward after that. After you take the x out, it's just 6x plus 2, right? Or 6. Sorry.
So in this case, I really like that we're saying, let's see what we can sort of factor out. I'm going to choose to frame it in a slightly different way because not all of the time everything cancels. And so let's maybe think about framing this in a way that'll actually work for a lot of cases. And the key thing that we're looking for right here is that we actually have one term in the denominator. Okay, so one clue that you can simplify here is you have a single term in the denominator. All right, so when we have a single term in the denominator, what we can actually do is, like folks were saying, we can take a fraction and we can split it up into multiple fractions, okay? And so if we're thinking about how might we simplify this, we could say that y equals 3x squared over x plus 2x over x. Okay, so when I'm saying let's rewrite it or let's simplify it, what we're doing is really taking a single fraction and turning it into multiple fractions. And the reason why we're doing that, in this case, things do reduce, but oftentimes when we get to this level, what we can do is use all of our exponent rules. Even if we have fractional exponents, we can use those exponent rules to simplify further, okay? So in this case, the first term here just becomes 3x because one of those x's reduces with the one on the bottom. So we'll end up with 3x. What about this second term? When we simplify that second term, what do we get? Exactly, we get 2. Okay. Now, in the quiz that you saw, quiz number 4 from last week, you'll notice that some of those, we could have used the same idea. Okay, I saw some people use like product rule, which is fine, because we had learned product rule last week, but whatever the fraction is or whatever the exponent is, you can still reduce by subtracting those exponents. And you might get a fractional exponent here, and that's okay. Or you might get a negative exponent there, and that's also okay. All right, but this ability to simplify really makes the problem way easier than what we're going to do in a little bit, which is use the product rule or quotient rule. So after we simplify, we can find our derivative. And so if our function is now 3x plus 2, what is our derivative?
Three.
Yeah, all it is going to be 3. And we can think about this in a number of ways. So if I were to think about using the constant multiple rule, I could say 3 parentheses 1x to the 1 minus 1 plus the 2 goes to a 0, right? The derivative of just the 2 goes to a 0, and this is the constant multiple rule. And this one is just the constant rule. But yes, and once we simplify that, we can say y prime equals 3. And in this case, I would say that is our simplification step. But in other times, we might have to do a little bit more work. Okay, but we get y prime equals 3. And so this was the method that I was looking for primarily in some of those last two examples. I think for quiz 4, you only had to do 1 through 4. So questions 3 and 4 that looked like a fraction, then this is what I would expect you to do. Okay. That's a great question, Noah. I'm wondering if anyone can explain this. Why did we get rid of that 2? Like, why did the 2 just go away? It's not the linear rule. Linear would be like, you could also use linear rule for this part, like 3x would be the linear part.
Power rule.
Yep, you could use the power rule, but one of the sort of special ones of those was the constant rule, right? So anytime you have just a constant, when we take that derivative, we get 0. And let's be really clear about our language. So maybe saying like when we take the derivative of a constant, 0. Okay. Another way that folks can think about that is sort of those, what are those invisible things that are really there? This is really x to not the 0, but x, or not 1, but x to the 0. Okay, so it's another way to think about that. Now I see a question in the chat about using a formula, and I just want to be really clear about this. Calculus is not just about formulas. Formulas are super, super important, but what I really want us to also be focusing on is this decision-making skills, okay? So right now we are going to use the formula. We are going to use that quotient rule. However, there may be cases where, let's say we get to an exam or a quiz and I ask you to solve things in more than one way, okay? And so this would be a really good example of when I might ask you to solve things one way, and then we're gonna do another method to confirm that same answer, okay? Are there any other questions about how we solved example 13 so far? Or has everyone's question been answered? All right, so on the right-hand side, what we're gonna do is we're gonna solve this using the quotient rule. And at the end of this, we should get the very same answer we got over there. We should get 3, okay? So let's go ahead and set this up. So anytime I'm using a rule, I like to go ahead and set things up. And for this one, we're going to have a U and a V, just like we had for the product rule, okay? So we're going to have U and we're going to have V. And the way we find the U and V is the U is going to be the numerator and the V is going to be the denominator. Okay, so in this case, our numerator is 3x squared plus 2x. So I'm going to go ahead and put that for my U. And my denominator is V. So V will just be x. All right, we okay with the U and the V just being the top and the bottom?
V is equal 1 over x.
No, V is just the bottom. Just the x. Whatever's in the denominator, that is our V. And yes, Kat, that will.
Are you all right? I'm sorry. Are you all right if we use f of x and g of x for those?
Yes, so I'm going to use U and V and F and G interchangeably. So either way is fine. Okay. All right, so once we find our u and our v, we're going to go ahead and find du and dv, just like we did for our product rule, okay? So let's go ahead and do our derivatives. When we take that derivative of u, we should end up with 6x plus 2. And when we take the derivative of v, we should get 1. All right. So after we set things up, because up until this point, it looks just like the product rule. The important thing here is that I know I'm using quotient rule because I'm dividing two things. And I need to know what formula I'm going to be plugging things into. Okay, so we're going to see the formula again below, but I just want to write it out here for us to take a look at. So when we find our y prime, we're using quotient rule. It's going to be v du minus u dv over v squared. Okay. And so all we're going to do is we're going to take the terms that we have above and we're going to plug them in to our formula. And we're going to be really careful about that. So our v is x. Our du is 6x plus 2. Minus u is 3x squared plus 2x. And dv is 1. The denominator is going to be v squared, or in this case, x squared. Okay. If you are a person who makes sign mistakes, I would put all these extra parentheses. All right. And that is a know yourself kind of thing. It's not a shame thing. It is, if we know that these are things we tend to, or mistakes we tend to make, let's set up situations for ourselves where we're going to be successful instead of just making the same mistake over and over again. Okay. So in this case, I put all those parentheses so that I know I'm going to distribute here. But when I take a look at the second clump of terms, I really am distributing that minus sign as well. Okay. So I need to be really careful about my signs here. Once we've plugged everything into the formula, then we just simplify. Okay, so now we just do some algebra and see what we get. And let's see, over here, I'm going to get 6x squared plus 2x. So I'm going to go ahead and write that up here, 6x squared plus 2x. And what happens when I take care of that second clump over there? What do we get? All right, I see a negative 3x squared plus 2. So close. Negative 3x squared minus 2x would be correct. Okay, so are we all clear on where that minus sign came from? Yes. Okay, I'll take that as a yes. So we want to make sure that we are really, really thoughtful about distributing that sign. Okay, gets you every time, not you specifically, but pretty much all mathematicians, right? We're working through the problem, we're working really quickly, and we forget. All right, now I am going to say one thing, okay, and that is when we use quotient rule, 99% of the time, I don't want you to simplify the denominator. So I'm going to put that out there right now. I do not want us to simplify denominators for quotient rule. The reason being, we're already doing calculus. We're already doing some simplification. The numerator, totally fair game. The denominator, just leave it. we've done so much work already. I do not want us to see us spend extra time simplifying that denominator. Now I said 99% of the time because this case, x in parentheses squared is fairly easy for us to say that is the same as x squared. That is probably the one exception. Everything else, I want you to leave it as something squared. Don't even worry about it, okay? So when you're looking at your quizzes, when you're working on your quizzes, or when you're getting to the exam, please know that that is an expectation in terms of simplification. I don't want us simplifying that denominator, okay? But let's see what we can simplify in the numerator. So I look through, I notice I have a plus 2x and a minus 2x. Those are going to go to 0. And then 6x squared minus 3x squared is going to give me 3x squared in the numerator. And then x squared is still in the denominator. I can reduce that even more and I'll get 3. And when we compare our two rules, we've done one where we simplify first and then take our derivative. And then we have one where we just jump right into the derivative. We end up with the same exact answer. Okay. So let me just leave this up here for a moment. Are there any questions about this particular example? That is a great question. I think when we get to example 14 and example 15, we will be a little bit more clear about when we don't simplify, okay? So as to Luca's question, let's see in number 14 and 15. And no, this would be a question where I would expect us to use I would not expect us to use product rule for this question. I think that was a really good way to approach it last week for quiz 4 when you didn't know the quotient rule. But as far as being able to simplify, all right, this is definitely going to be something like I might give you a question that looks like a fraction, but I would want it to be something you could work through fairly quickly. And I think the simplification one might be quicker in this case. All right. But there are going to be cases where we're not going to be able to simplify, and then we want to be able to use our quotient rule. Okay. All right. So here is the formula. Here's one version of the formula. Okay. So if two functions are differentiable, meaning you can take the derivative of each one, then the quotient is differentiable, and you have a rule that we call the quotient rule. Okay, so this is our quotient. Right. So this is one form that folks like. I did see a few other versions that, you know, in terms of memorizing that rule, some people like better than others. So if I were to use the derivative of u over v, can someone tell me what my denominator would be here? So let's kind of use the rule that we're given and use it with some different letters and see what we can generalize. What would our denominator be here?
Squared.
Yeah, so we're going to take our v, which is in the same place as g, and we're going to say v squared. Excellent, excellent. Okay, so it's going to be v squared because in this case, our denominator is v. Okay. What about in the numerator? How do we apply the rule that we see up here with the F and G letters to make them true for U and V letters? Yeah, great job. So du would be the same as our F prime. V would be the same as our G. Good, good. Okay. Now, again, if I write du times V, it's the same thing as writing V times du. So a lot of times we just put the letter first and the derivative part second, but it depends. Again, you'll see different styles where sometimes the derivative comes first and sometimes it comes second, but when we're multiplying, the order of that doesn't actually matter. Okay, and then minus u dv. All right, so just practicing using it with different letters is one way to make sure you know what order the rule goes in. Okay. Alternatively, some people like to think about this in terms of sort of a function that is higher and a function that is lower. And so sometimes we call the one on the top high and the one on the bottom low. Okay. And so if we were to practice using those letters in this quotient rule, what would we get for this first term? So the one before the minus sign, what would we get there if we use these letters? Yeah, so our V is like our low, okay? So instead of V du, we might get low d high, and that just means low times the derivative of the high minus the high function times the derivative of the low function, high d low. And what does that look like then if we write the denominator? Yeah, we could say low squared. So some people like to, oops, write it as low squared, and some people, anybody in here have a low? Not one? That's not true. I've not had that happen before. Well, if you have a Lolo and a Lola, then you know what I'm talking about. If you don't, that's okay. But this might be a more fun way to remember that. So I know some folks like to think about, like, what are those things called? Where you have like a letter and each letter spells out a sentence, but it helps you remember an acronym. So anyway, memorization tricks. This could be one if you think about sort of like a more fun way to remember it. Some people like the low D high minus high D low over low low. Some people like V and U. Some people like F and G. So lots of different ways. But the most important thing about these is that everything is sort of in the same place as its corresponding parts. Okay. So let's go ahead and work through two more examples. And I think we'll be really explicit about how we're only going to simplify the numerator, but we are not going to simplify the denominator. Okay. So with that, let's go ahead and take a look at example 14. All right. So differentiate y equals x squared plus x minus 2 over x cubed plus 6. And in this case, I can't simplify by breaking this up into multiple fractions, okay? If I did want to break this up into different fractions, I would get x squared over x cubed plus 6 plus x over x cubed plus 6 minus 2 over x cubed plus 6. So if I tried to simplify by breaking it up into different fractions, I could break it up into different fractions, but all I've done is say now I have to use quotient rule 3 times. So it didn't actually make anything easier for us, okay? So we kind of try that out. We realized, oh, maybe that's not really gonna be super helpful. So what we're gonna do is use the quotient rule, okay? So let's use our U and our V since Diego seems to be fond of that one. So we'll go with our setup. U equals x squared plus x minus 2 and V equals x cubed plus 6, okay? So if we have that, take a moment in the privacy of your learning space right now and go ahead and find du and dv using the rules that we learned last week. And once you have those, maybe go ahead and type those into the chat. I don't believe we have an x plus 1. You're just trying to throw us off. See who's actually doing this. Yes, 2x plus 1. So we're going to bring that power down to x to the power of 2 minus 1 is 1. Plus the derivative of x is 1. The derivative of negative 2 is going to be 0. I'm just going to write the 0 so that we can kind of see that each one, so x squared becomes 2x when I take the derivative. X becomes 1 when I take the derivative. And 2, when I take the derivative, I get 0. You do not have to write that 0. I think it's a nice sort of training wheels in the beginning, so we don't think that things disappear, but we know that the derivative is 0. But again, I'll leave that up to you in terms of a personal preference. But dv here is going to give us 3x squared. I'm going to do that plus 0 again, so we know that the 6 goes to a 0, but I can really just write that as 3x squared, okay? So how do we feel about just the setting up the u, the v, the du, the dv? Okay, that step should be pretty quick for us. If this is a step that we're not feeling super great about, I would go and find a lot of practice problems in terms of power rule stuff, okay? So that's a great question. Okay, 2 really good points here. So one question is, should we always try the simplify method first? I like to do that because a lot of times it'll get you out of doing quotient rule or something a little bit stickier. It's maybe less important in this class, but if you plan to take Calc 2, or if you plan to take all the way up to differential equations, I would really encourage the simplification because it can save you some time when it's in the context of a bigger problem. Okay, so I think it's a good thing to develop a habit for, but I think it also depends on how far you plan to go in math. All right. The second question here, Luca, super valid. U and V, I'm not sure why mathematicians picked U and V because it seems like if you have slightly not perfect handwriting, it can get very confusing very quickly. As a rule of thumb, I usually write my u's with a tail. I don't know that I always did that, except for math. It seems to make more sense because this has the tail and this is pointy. But even if I start to write them faster, if I don't have the tail and that's not quite pointy, then now they start to sort of become much more similar, right? So I would just encourage you, if you want to use U and V, making sure that that has a tail is one helpful way. Or if you're like, you know what, Judy, my handwriting, not so good, F and G are letters that are significantly more different than U and V. So F and G might be a better choice for you if you feel like, you know, the U kind of starts to look like a V. All right. So we've set things up. Now we are going to sub things into the formula, sub into formula. All right. And so our formula, because we are just doing our second example. Oh, good. Just because we're doing our second example, let's go ahead and write out that rule. Y prime equals V du minus U dV over V squared. And we're going to go ahead and substitute in all of our things. X cubed plus 6, 2x plus 1, x squared plus x minus 2, 3x squared. And on the bottom, I'm going to put x cubed plus 6 squared. Okay. So how do we feel about the setup and plugging numbers in to the equation? Or not numbers, but expressions. Okay. Once we've subbed everything into the formula, okay, that is our calculus step. That middle step is the calculus step. And then we're just going to simplify. And let's maybe make a note to ourselves. Numerator only, okay. All right, so let's see what we get. Let's start by foiling out that first term. And when we FOIL out that first term, we're going to get 2x to the 4th. Let's see, plus x cubed plus 12x plus 6. So all of this becomes these first 4 terms. And then in the privacy of your own home, if you could multiply out the second clump of things and including this minus sign, tell me what I should write for the second part. Right, so what are we getting when we multiply that out for that second piece?
I got negative 3x to the 4th minus 3x to the 3rd plus 6x squared. That's with the,
Yeah, sign already distributed. Excellent, excellent. All right. Any questions about that? 3x to the 4th. 3x to the third, and then that's going to be a 6, not a 5 at the end. Okay, and so when we have that, now we can go ahead and clean this up. Let's see what terms reduce. So we have 2x to the fourth minus 3x to the fourth gives me negative x to the fourth. X cubed minus 3x squared gives me negative 2x cubed. Then I have plus 6x squared plus 12x minus plus 6, right? I think that is what we should get when we clean up that numerator. And then here's what I mean by don't simplify the denominator. I don't need you to FOIL this out. I promise you, you don't need your time to FOIL that out either. Leave that bottom as something squared, and that's it. Okay. All right, I'll give you a moment to see if you have any questions. What coefficient are you talking about? So every question is going to be different. You have to use the information from the first question or from each question. So I'm not working on example 13 now. This is a different question. So I want to use the numbers and the exponents and the coefficients from this question. Okay, great. All right, so let's do one more quotient rule example, and then we will take our first break, all right? So one more quotient rule example. We're going to follow that same idea. So if I were to do a mental check to see if I simplify this, will it make my life easier? I would not really be able to split this into two fractions. This would be as far as I could go. So in terms of splitting fractions, I can't really split into multiple fractions here. So that's a good sign that I'm going to need to use quotient rule instead. Okay. And so let's maybe use our, do we want to use F and G in this case so we don't do accidentally the wrong letters? So F traditionally talks about the numerator, whereas G traditionally talks about the denominator. Okay. And so if we establish these functions here, I think that our derivatives, in order to find our derivatives, it might be really beneficial for us to rewrite F. And how would I rewrite F so that it would be easier for me to take a derivative? Yeah, 4x to the 1/2. Okay, so I'm just going to rewrite that. So in this next step, when I take a derivative, it'll be a little bit easier. So let's say F prime and G prime. I'll give you a moment to find those derivatives, F prime and G prime. Let's see what we get.
For F prime, I got 2 over root x.
2 over root x. Okay. So I agree with that. I'm going to write out some extra steps here just so we get to that. Okay. So this step in particular, if you're not sure where that 2 over root x came from, was probably very helpful to explain that. And then what do we get for the g prime? 2x, I agree. And so if I were to, again, say that x squared, when I take the derivative, I get 2x, minus when I take the derivative of 2, I get 0. And so that's how we get that 2x, okay? Now, I will say that especially this week and next week, when we learn a lot of other rules, this setup step is going to be so important. Please double check your setup step, because if things are wrong here, it trickles through the entire problem and then you're kind of out of luck, okay? It's really hard to come back from making a bunch of mistakes in the setup piece. So we want to make sure that that is accurate. But once we've set those up, we're going to sub into our formula. And again, trying to build that muscle memory. I'm going to write out that formula. So we'll have f prime g minus g prime f over g squared. So for me, I have other problems. I can make my u and v look different, but my f and g have these aggressive tails on that. So it's actually really hard for me to write this one. It's probably why you'll see me write more with the u and the v. But again, that's totally a personal preference. It doesn't matter what letters you write, as long as they correspond to things in the right order and the right place, okay? All right, so let's plug things into our formula here. Our f prime is 2 over root x. Our g is x squared minus 2 minus g prime, which is 2x, times f, which is 4 root x. And here's another great example of when I don't want you to simplify. You're just going to leave that bottom as x squared minus 2, that whole thing squared. Okay.
I have a quick question.
Absolutely. What's up?
Back when we got f prime, we put it back into the 2 over the square root of x, because that was the way the original question was written, correct?
Mm-hmm. Yeah. All right. So in terms of simplifying for our, yes, good catch there. It is the y prime. In terms of simplifying our y prime here, all right, I would say this. Let's take these two terms and put them as a single fraction, okay? So in other words, I'm going to do 2 times my x squared minus 2. So that'll give me 2x squared minus 4 over the square root of x. That's what my first term is going to simplify to. Minus this part here, I'm going to get 8x square root of x. I'm going to put that all over x squared minus 2 squared. And that is all we're going to do to simplify. Okay. My primary concern here is not that we are aggressively simplifying, but my primary concern is, can we set this up? Do we know what rule we're supposed to use? And can we plug things in the proper place? Okay. All right. So before we move on to our break, are there any questions about the quotient rule? right, so let's see, what time is it? Looks like it's 7:57. Let's be back at 8:08. All right, so I'll see you folks back here in about 10 minutes, and we're going to move on to 3.3 part 2. So we'll get a chance to practice more about the rules that we've learned and look at different types of questions that still ask us to do the same thing. Okay, so I'll see you folks back here in about 10 minutes.